Hi, this is Sean with Geomagic, and today what I want to do is talk a little bit more in detail about some of the operations and options within the Mesh Sketch command. A couple months ago, we did a 20-minute webinar on our product spotlight series on the subject of 2D and 3D sketching. And overall, I think the applications engineer did a very good job explaining some of the options within those tools. But um, part of what the reason that I'm making this video right now is that I don't think the AE expanded on setting up a 2D cross-section mesh sketch and going over some of the options in that command in more detail. And I think that some of the options in that tool are really interesting, really useful, and sometimes overlooked by a lot of people. So I'm just doing this on the fly, off the cusp. Not a ton of preparation went into this, so it's not going to be the most polished thing you've ever seen, but just to shed a little bit more light on what is available in especially the cross-section tool and how it relates to some of the other functions within the software. So as you can see here, I've got the trusty, rusty Partifact 3D Systems Geomagic Partifact on the screen here. I've region grouped it really only for the purpose of pre-aligning this to the origin. So I've already done a line wizard to get the scan data in a coordinate system so I can turn off my regions right now. And let's talk about some of what is available in the mesh sketch command. So obviously I can access that in a couple of different ways, right? I can go in my home tab here. I can find the mesh sketch command, which is somewhere. I can right click on a reference plane. I can find the mesh sketch command there, or of course I can go to my sketching tab and find it there. So 2D sketch, mesh sketch. And no matter what method I choose, I am always going to need to find a cross-section plane in order to create that cross-section. So when we're doing a planar method, we'll get to this rotation method in a minute here. I want to make sure that I'm finding a plane that I want to put my sketch on. And that's actually kind of important because this base plane here is always going to be the plane where my sketch lives when I end up creating it in the next step here. What geometry or what data from the scan that I use to generate the polylines may be taken from other cross sections offset or otherwise from this base plane, but the sketch that I end up generating is always going to live exactly on that base plane. And I'll get into some more detail with that in a second here. Um, Obviously, if I am trying to create a cross section of maybe just the basic perimeter of this part, totally appropriate to offset slightly down into the piece a little bit here and just get a more clean cross section of the overall kind of rectangle with rounded fillet edges or corners there. Um, One thing that's overlooked a little bit though is the fact that I'm not limited to just creating one cross section on this part. So you can see here the section polyline that I generate. I've actually got a list. Right now I'm only generating one of them, but I have three icons next to that section polyline. I have a select none, and I think I need to move my mouse off here so I can get my context menu to show up. Select none, which is just get rid of it. That feature that I am trying to not select or select there. I can add another cross section, or I can delete a section. So if I don't like that section one at all, I can delete everything and need to kind of start fresh by creating a new cross section here. So obviously we're not going to trash too many of our cross sections unless we're doing a multi-section view here. So for example, if I want to maybe do multiple features here that don't all lie on the same plane, I can offset my cross section down into the part so I can get a overall perimeter cross section there, but I can create a second section, right? So now I've got, since I deleted section 1, it's going to have offset section 2 and offset section 3, and that's going to allow me to make a second offset here. So if I just move this way off of the part here, I can still see that there's a solid pink line where my original offset was. There's a dashed line, which is that cross section projected onto my sketch plane, because remember that we're always creating a sketch on that plane that we've selected here, this base plane, my right plane. And if I'm adding another section here, if I drag this cross section down, I'll get two more of those features, right? I'll get another dashed section, which is the projection of this new cross section offset from the base plane there. And so I can toggle between these, right? I can, if I want to pick up some of these features here, these 3 holes here, they are, or at least where I currently am, that's 1/4 of an inch off of the plane. And if I go back and want to modify my other one, that's a, 300 thousandths of an inch off. Maybe I want to set that to 1/4 of an inch in the opposite direction. And so I can toggle between these two and make my edits as necessary. And it's going to combine those cross sections into a single feature when I get into my actual sketching mode. So let's just step aside for a quick second here and take a look at what that looks like. Right? If I go into sketch mode, I'm going to see not only the 3 holes, but also some of the other data here that I didn't clip out, as well as the complete perimeter of that part. Now, if I zoom in though, right, what I would expect to see if this part was a pure, true vertical wall part is that the perimeter on the positive and negative offsets should sit right on top of one another. In this case, they don't, right? This indicates to me that this part has a small amount of draft angle to it, where these walls are not vertical, or at least perpendicular to the cross section. They have a small amount of an angle to it. If that is of some concern or some interest to me, maybe I want to investigate that a little bit further. So what we can do here is if I hit OK, the sketch will save, even if I didn't, convert any of those polylines to actual sketch elements. But if I right-click my sketch in the history tree, I can either edit the sketch and just go back into my sketching tools here, or right-click, edit mesh sketch setup. So this is actually an option that takes me into the first step of mesh sketching. And I think that this is sometimes overlooked by some people. I used to be an instructor for the software, and I would see a lot of people, make a change to their sketch, or make a sketch that they weren't happy with, and instead of just editing the sketch, they would just delete it and start from scratch. And of course, that's not maybe as efficient if we've sketched 100 elements or something. We want to change one of them. Don't delete the whole thing. You can just edit the mesh sketch or the mesh sketch setup. So if I hit the setup, that takes me right back into this. And again, I have those 2 sections. They were renamed, but there's still the same 2 sections here that I can play around with. Let's, that's all pretty straightforward so far, at least what we've talked about there, the multi-cross section. This is just going to enable me to bring other features at different offset into the same sketch. Now, I'm going to go ahead and delete the second section here, and let's talk about that draft angle a little bit. In the options down below, that draft angle that I have there is a selectable option. And if I know, if I'm dealing with injection molded parts or some other parts that have a release angle, and I know that I'm supposed to be dealing with a 1 degree or 1.5 degree or whatever it is, I can insert a known amount of draft in here, and the software will compensate for it. If I don't know what the draft angle of these walls are and I want the software to estimate it, we have our handy dandy magnifying glass magic wand type icon here that says estimate draft angle from mesh. And so this is going to run on all of the scan data cross section that is currently being shown. So I only have one offset section here just to not complicate things a little bit. But if I zoom in, and maybe I'll be able to show this. I know this only got a small amount of draft, but if I zoom in and let's see if I can find an angle where this actually makes sense to show, and I change my offset, I would expect that to grow or shrink ever so slightly. Like the overall dimensions of this box are going to grow or shrink slightly if I have this estimate angle off here. Maybe a better way to show this is if I go as far down into the part as I can without moving off of it, but keeping a complete cross section there, so about a little over half of an inch of depth in there, and then actually create a cross section sketch here. Let's kind of identify this draft angle a little bit differently. If I just sketch the external perimeter here, this is with no draft angle correction on, by the way, just as a heads up. So I've got a more or less exact fit to those 4 walls of this extrusion here. I can use my accuracy analyzer obviously to see where the major deviation areas are. Of course, they're always going to be in the corners here where I haven't sketched these radii in. 3/4 thousandths of an inch of deviation in that area. The worst I think here is about 10 thou right up towards this corner, just under 10 thou. So that's at the maximum extent of the part, 0.53 inches in. Now, if I keep that sketch where it's at, but edit my mesh sketch setup, and don't go all the way down into the part, maybe just go right on the main sketch plane, the highest point where I have a complete cross section here, that's not part of this fillet at least. So that's, you know, 0.1 inches in, and go back out, edit my sketch here. They're going to be different sizes, right? This wall is going to change the position depending on how far off that base plane that I go. And so I'm starting to see a little bit of deviation here. There's a little bit of you know, a gap between the cross section from the polyline and the sketch that I had built before, and that's all due to the draft angle. So in this case, vector multiplier is kind of screwing me up here, but I've got 10 thousandths of an inch of deviation, 11 thousandths of an inch of deviation in areas where I had almost none before. And this area here, which I knew was kind of the worst of it, instead of having about 10, 11 thousandths of an inch, I've got more like 19, 20 thousandths of an inch of deviation. So that's how much this part is changing in size due to the location of the cross section. So that was mainly just to kind of prove my point. That was more of a, yeah, this part does have draft. So if I go back into my mesh sketch setup here, that draft angle, if I select it and then I hit estimate, it's going to calculate that the angle of these walls are about 1.36 on average degrees all the way around this part. That's also maybe taking into account this little area here that's part of a hole. So maybe if I drop this down a little bit into a pure cross section and estimate again, I might get a slightly different result, 1.25 degrees, okay, or 1.2403. And just like everything else in Design X, if we want to use the original design intent of this part rather than just some extracted value from the scan, I do have override capability here, and I can type in 1.25, enter, and it will use that. I almost called it a whole amount or whole value, but it's a fractional value. At any rate, now when I go into my sketch here, it doesn't matter where I create that cross section, it's being compensated for that draft angle. And so if I build my rectangle, or I probably could have left it from before and just re-snapped it to these faces here, it doesn't matter where that offset is placed, it's being compensated for that draft angle. So now if I extrude this, and I'll do it in both directions because I'm above and below, or I have part above and below here, I can see that with a straight extrude, I'm going to get some deviation values that kind of vary above and below the sketch plane here. I should have green pretty much right where I have sketched it, but I've got some high areas on top and I've got some low areas on bottom. But if I add in my extrusion here, draft, and I type in that 1.25 inch draft, and we'll let it calculate for a second here because I'm doing some screen sharing, 1.25, and let it rebuild the view, we should see all green. Now I'm kind of wondering here if the draft angle is actually going the wrong direction, or it actually looks like it is. It's since I'm doing a mid-plane extrusion here, it's actually kind of all over the place. So it looks good on the above side, so maybe I need to do this as a extrusion in two directions. So it's actually, you can kind of see that there's a bit of a V shape like this here. So at any rate, you know, I need to change how this extrusion is being built. So on top, that looks good. We'll do opposite direction instead of mid-plane. I'm just going to turn this off so that it goes a little bit quicker and I can make sure I'm doing things properly. So flip the angle there so it's kicking it out. You can see a little bit of a difference, kicking it out the correct direction. Again, we're doing 1.25 degrees that way. And if I let it build and run my accuracy analyzer there, I should see pretty much all green all the way around in the areas that this extrusion actually fits the scan data. Wait for confirmation. There we go. Of course, I haven't modeled the fillets in yet, and you know the part may not be perfect. It may not be a perfect rectangle, but overall that is a much better fit than if I were just to turn off the draft on both of these here, show the deviation there. I'm going to see a lot more red and blue. I can even see a little corner of the part kicking out here that's just not fitting properly. So that's how the draft angle works. It just kind of analyzes, basically takes horizontal or cross sections, multiple cross sections above and below, and kind of identifies how much they vary, and it converts that into a degree value. One of the other things that I can do in this mesh sketch setup, well, actually, let's do another mesh sketch here, right? So we've already built this feature, and just to make things easier on me, we'll go ahead and use the top region to cut this feature so that I can kind of see the next thing that I'm going to try and model here. I can actually use regions to cut things, by the way. This is not part of the initial concept of this video, but it is going to make things slightly easier for me. So if I go to my model tab here, hit cut, I can select that region, even if it's a organic shape, and say I want to use that region to cut this solid body. If I use a region, it gives me this some similar tools to what I would see in the mesh fit command, which is right there. A little bit pared down in terms of what the mesh fit command can do overall, but basically just a couple analogous features here. And that's what it really is doing underneath. It's running a mesh fit, generating a surface from that region, and then using that surface to cut the solid body. And so I can change my my setup here, maybe allow a little bit more deviation, maybe make it a little bit easier for that to build. Yeah, and sometimes in this case it actually doesn't build a big enough of a surface for one reason or another. So I'll let it mesh fit there and actually orient this thing properly so that it fits and cuts all the way. Sometimes I'm not sure why it doesn't make a complete rectangle, but anyways, this will work. That surface cuts this solid, keep the bottom portion. And so here's actually the reason that I wanted to make this video in the first place. I had a customer kind of ask me about they've got a portable CMM arm, and they are trying to probe hole locations all over a large car essentially, or a vehicle chassis, and they're having some struggles with some workflows inherent to that, unfortunately. So what I recommended them do is just scan the top of the surface so that they can see where there is scan data and where there is no scan data, and they can use some of the mesh sketch features to figure out where that whole location is. And so what I want to point out here, and I'll hide my solid body and I'll hide my regions, is that in this case, right, I've got some missing data. It was hard to get line of sight into this slot feature, both slot features. There's two stack slots. And so taking a cross section, especially of this lower section here, taking a single cross section of this that makes it really easy to represent like a complete slot is either going to be fairly challenging or completely impossible. In this case, probably more or less completely impossible, right? This is about the most complete of a cross section I can get in this area. I'm not even getting, a quarter of the circle on this end. I'm not even getting, all of both of these lines. I'm getting no data on this backside because I'm just doing a single cross section here. So, we talked about before adding maybe a second cross section and doing a slightly different offset. And that's one approach. Maybe I do 3 or 4 of these things. But the other alternative to that, and I think the more appropriate alternative, is this silhouette range. Now, if I zoom out, right, I can see that on this kind of, in this case, I'm just isolating this one little feature, right? This bounding box here can just make sure that I only take a cross section of what I want to see rather than the entire part. So that kind of helps me hone in on something. Instead of taking 2D cross sections, what I can do is I can use this silhouette range, right? So I've got a long skinny arrow, and that always defines my offset. But what I was going to point out a second ago is I also got a short fat arrow here. And this defines a silhouette volume, more or less. And it's analogous to this value here. If I pull up on this short fat arrow, essentially what I get out of this is the same thing as I would get if I were to be, place this part on a table, take a flashlight out, and shine the light down here. And where there is light on the surface of the table is going to be the region internally here that is defined by this border or this boundary of the scan data. And where I get dark is everywhere where I actually do have scans. So what I get, and especially if I, again, shrink my bounding box down here so that I'm only looking at this internal slot, right? I can just kind of ignore the rest of it, is that feature. And I've got messy data on this side, but I do have a much more complete polyline. Might help if I hide my scan data. Much more complete polyline on that internal feature. So now when I go into my sketch command here, I've got a complete line. It's not the prettiest thing out there because I am missing some scan data, but it does make it a lot easier to fit my slot entity to. Okay. So I really, really recommend using this silhouette tool anytime where you have incomplete data, sheet metal parts, trying to find a hole in that, where you just can't get a good reliable cross section all the way through the feature that you're trying to model. This is a great alternative. Okay. So now, of course, I can use that and use my context menu to help me find my extrude command and create a cut operator there and build that feature. Do the same thing, on some of the other things here. So that's most of what I wanted to talk about with regards to like the mesh sketch setup, at least. Let's see if there's any other options in there that I missed. So we talked about the base plane being basically immovable. We can offset from it, we can silhouette from it, but the sketch always exists on that plane regardless of where our cross section is actually taken from. We talked about adding multiple cross sections as well, or using the silhouette to kind of help us isolate a feature that's maybe a little bit harder to take a single cross section through, at least. We've talked about the draft angle here. One of the things that we haven't talked about is this limit to regions and exclude round corner. Exclude round corner is not a feature that I talk about too often. I think basically what it just does is it does something that's very similar to some of our modeling wizard tools, where it basically ignores fillets and it creates cross sections that are more just perfect intersections of lines rather than a fillet across them. I'll have to check the F1 here. Actually, we can probably do that right now just to see if I am right in my assumption, but I've honestly never used this feature before. So if we are confused about something, it's a great thing to point out. Just hit F1 on your keyboard, or I thought there was a way to get to it up here. But yeah, F1, just like any other software, will bring up the help menu associated with whatever tool you're in. And we can scroll down here until we find a section called Options in Detail. And so that's going to go through every little one of these radio buttons, checkboxes, that sort of thing. And we'll just keep going down until we see Exclude Round Corner. So Exclude Round Corner removes round polylines less than a specific value. This option can be used to create a sketch without filleting. So it's exactly what I said. In this case, if this radius here is 0.1 inches and we say the exclude round corner is smaller than 0.2 inches, it's just going to ignore that and not do that. So that one nice way to kind of help you clean up your mesh sketch and only see data that's a little bit more relevant to you. The limit to regions and average section here, I actually want to talk about that in a slightly different way. I don't want to use that. It's not something I typically use when I'm doing a mesh sketch by myself. There may be a couple opportunities to do it, and it really just helped me kind of hone in on areas that I'm interested in, or kind of controlling the cross section that I get a little bit better. But I think they're a little bit easier to show when I use other features. So let's do it this way. A lot of you have probably used the modeling wizards before, the loft wizard, the extrusion wizard, revolve wizard, sweep wizard, even the pipe wizard, which isn't on the tool here, or toolbar here, the ribbon bar. But maybe aren't quite sure what kind of magic goes in underneath the hood. And so let's talk about how these tools here create certain features. I'm going to do extrusion wizard first, right? So Extrusion Wizard's pretty straightforward. I just find the mesh, grab my regions here. I select this anything that's going to help me define my sketch as a side. I'm going to select this feature, that region, or I can select this plane as my bottom. And in this case, I don't really have a top. I just want to extrude cut it out from the remainder of the solid here. So the result operator I'm going to get is a solid cut. And I don't want to do through all. I just want to do up and away from that bottom plane there. Now, if I hit next stage, of course, that's just going to generate a preview for me. And of course, here I can alter a number of things, including just the value or height of this extrusion. Some other things with my mesh sketch as well that it generates, and hit OK. Now, Extrude 2 is the last feature that I've generated in the feature tree, so we're going to see a number of things populate in my history tree here after I hit the checkbox. So hit that, and the software builds me underneath Extrude 2, plane 1, sketch 3, Extrude 3. And so this sketch 3 mesh looks exactly like this sketch 2 mesh, right? It's just another mesh sketch. The software creates a mesh sketch. Let's take a look at how it generates that mesh sketch. First of all, it created a plane. If I had chosen to reuse this plane here, this system plane, it would probably not have done that. But in this case, it created its own plane since I built it off of a region instead. And if I right-click that mesh sketch, I can do the exact same edit mesh sketch setup that I did before, and take a look at what it did. So here's what we get. It shows me the region in question, and it shows me a number of pink polylines here. If I use this drop-down, I can see that the software actually create 10 offset sections from that base plane that we created there at whatever distance, between those two, about a tenth of a millimeter. I think basically it just takes the overall height to the top of that region, divides that height value by 10, and whatever the gap distance is between them comes in there. When we look at this, we notice that only that one region that we've selected there is being cross-sectioned, right? Otherwise, usually we'd see, some of the rest of this object be sectioned. And the reason for that is because the wizard tool by default uses this limit to regions option, where it only cross-sections that region of the scan data. If I deselect that, you can see that I get cross-sections all over the place on all of my features. And that's obviously going to be really difficult for the software to create a sketch of just that feature. So when we use limit to regions and we use only that revolution region, it makes it easier to fit individual sections there. And the average section basically identifies that, similar to that draft that we were doing before, each one of these offset sections here may vary slightly from one another. So if we turn this off and go into the sketch itself, right-click, edit sketch, what we'll see, and I'll just delete the sketch elements here. Oops. What we'll see is a thick line, and if we zoom in further and further and further, we'll see 10 of these cross sections all really close to one another. I'm zoomed in so that this is about 5 thou here. So there's about 5 thou of variation between all of these sections as they exist on that cross section plane. So what average section does is it averages those 10 sections, right? It takes out any variability if this isn't a purely vertical wall shape or anything else. So if I edit that, average the section again, it just mashes all of those individual cross sections into a single one at the average, which is much cleaner and much easier for the software to basically use the auto sketch command to sketch those features. Okay. Yeah, that's basically it, except for one major thing that I haven't talked about yet. And I've done this video in this order, kind of haphazardly, but kind of luckily got to this point where I'm in a perfect setup to talk about the one final option that I haven't talked about in the mesh sketch command. Remember what it is? Well, let's open it up and take a look. So find my sketch tab here, create a mesh sketch. Yeah, I didn't talk about this radio button at the top here. We've only been doing planar offsets so far. We've only been doing offsets or basically all sketches from a single plane. But that's not the only thing that the software can do. Instead of doing an offset in a linear direction, we can also do an offset in a rotational direction. That's going to be this rotational method here. So this rotational method is going to change my setup options so that now I have a central axis along with a base plane. And I just so happen to align this part so that these two planes here, this front and this top plane, intersect along the axis of revolution of this cone sphere feature here. So what I'm going to do is I'm going to say, well, let's take a look at what we can select as a central axis. Obviously, if we had a vector or even like a cylindrical or conical or otherwise revolved CAD face, we could use the axis there. Or we can kind of create a vector on the fly just by clicking one plane, two plane. And it calculates their intersection as an axis, which is really nice for me. I don't have to do this as a separate step. And then I can choose which of those two planes I want this sketch to be on. Okay. And from here, everything's pretty much the same as the planar method. I can shrink this down, my bounding box down, so that I'm only isolating the feature that I'm about to sketch here. I can, use, instead of the linear arrows, I can use this arc to rotate my cross section about that axis. And just like in planar mode, I've got that solid line or solid kind of polyline cross section. That's showing me, where the cross section is. And then I've got that dashed polyline in there showing me where that projection is going to end up onto my sketch plane. So that when I sketch this thing, it's always going to be on the top plane, right? And just like we had in what I'll call 2D mode or the planar method here, I also have a silhouette range. This is a little bit harder to give an analogy to because we can't really bend light. I'm not a physicist. I think maybe it's possible, but can't really bend light. But basically this works the same way. So if I'm missing data in certain areas here, I can grab this fat arrow and now I'm creating a wedge, right? Instead of just a 2D cross section, I can take kind of a 3D cross section and all of the data within this wedge here and all of the data that's within that wedge is being compressed down and averaged and projected onto that plane. So maybe not something that's actually physically possible, but something that is very, very helpful. Again, primarily when we don't have a complete scan, we can, more or less take, infinite numbers of cross sections and project them all and kind of create like a single section here. Same options below that, obviously, and of course, when I go into my sketch mode, now I can sketch this out and revolve it. So really hoping that that shed a little bit more light on some of the details in the mesh sketch command. And yeah, have a good day. Take care.